Good evening, YouTube. It's me again, and tonight we'll have a short video on an introduction to the Pythagoras Theorem. If you have been taught this theorem in school and you would wish to explore how you can use this further, there's another video on, I think it's named Revision to Pythagoras Theorem. This is an introduction. This video is for you if you are unsure of what your teacher is teaching in school, or you just forgot what the Pythagoras Theorem is all about. The Pythagoras Theorem is useful for all streams in Sec 3 and Sec 4, normal technical, normal academic, as well as for express students. So it's useful for you to make sure that you know this useful theorem. For those of you tuning in for the first time, I do ask you to excuse me for my voice. It's a little bit husky today because I was yelling at my students yesterday when they were walking for their cross country. So let's go. So what is Pythagoras Theorem all about? Well, it's a very simple theorem. And over 2,000 years ago, in fact, the dude called Pythagoras found out that if he looked at a right angle triangle and he made a square of all the sides. I mean, let's say this is the one side. He makes a square of that one side, and he does the same for the other two sides. He realized that the area of this square here, this square, and this second square, the area of these two squares when they add up together is you get the area of the third square over here. So if we remove the triangle from here, this is what we get. Similarly, this is what we get. The first square, the area of the first square, plus the area of the second square gets the third square. Now, I do not know why he was doing that, why he was playing right angle triangles, but it's really quite cool that someone could notice this relationship between the sides of the triangle. So if I may repeat, what Pythagoras found out was if you form squares, using the sides of the triangle. Okay, so you have the one side of the triangle over here, and you form a square. Okay, and the other side of the triangle. Okay, and you form a square. I'm sorry, and you form a square with that side. Okay, and then you add the areas of these two squares together, you get the area of the third side, the square that is formed by the third side. Okay, so that's what he discovered. Pretty cool stuff, but what does it mean to us? So the formal definition of Pythagoras theorem, in a right angle triangle, the square of the hypotenuse, which is the longest side of the triangle, okay, the longest side of the triangle is called the hypotenuse, is equal to the sum of squares of the two other sides. Now, right now, we need to ask ourselves, what is the hypotenuse? Okay, students usually have problems pronouncing this word as well as spelling it. Okay, the hypotenuse is the longest side of a right angled triangle. Okay, if you look at the right angle triangle here, the right angle is over here. Usually, how do we identify the side? If you can't see that this is the longest side, the hypotenuse is usually, or no, it's not usually, it is always the opposite side of the triangle, which is opposite the right angle over here. So once again, what is the hypotenuse? The hypotenuse is the longest side of a right angle triangle. And if you have problems looking for the longest side of a right angle triangle, just look across from the right angle located inside the triangle. Okay, so you actually can forget about this formal definition because no question would ask you define a Pythagoras theorem. No, in fact, they will most probably ask you to use the mathematical formula associated with the Pythagoras theorem. We are going to touch on it next in the next slide. Oh, hang on, it is this slide. So what it means, if you look at this green square over here, if we name the sides A, okay, B, and C, it's always a good practice to name the hypotenuse C, because you'll see what I mean. Haha. Okay, so if we revisit back what we did just now, that the sum of the areas of the two shorter sides of the triangle, it would add up to the area of the square that's formed by the longer side. Okay, so we have to look at what the area of this is. Now, since this is a square, both sides is equals to a, and therefore the area over here equals to a squared. Similarly, the length over here is b. Given that this side is a b and this is a square, therefore the area over here is b squared. And by the same logic, the area over here is c squared. So what does the Pythagoras theorem, how is it expressed in mathematics? The sum of the area of the two squares formed by the two shorter sides, a squared plus b squared, area of this green square plus the area of this orange square equals to the area of this yellow colored square over here. So this is the formula that most students remember. A squared plus b squared equals to c squared. Always remember that c squared is your hypotenuse. Always label c, always try to make c your hypotenuse, okay? Because this prevents confusion, and this makes sure this makes sure that you get the formula in the right place. A squared and b squared, doesn't matter which side is a squared and b squared, but make sure that you assign a squared and b squared to two separate sides, okay? So let's look at a few examples over here. So if we assume, let's try it, okay? So we just name this as before a and b as well as c. Now, if I give you, if the question gives that this is b equals to 3 and a equals to 4, how would you find c? Anybody? Oh, I'm sorry, I forgot that I'm not in class. Okay, so we make use of the formula a squared plus b squared equals to c squared. Okay, a squared is 4 squared plus 3 squared equals to c squared. 4 squared is 16. 3 squared is 9. Okay, therefore c squared is 25. Now, the question would usually ask you to find c. So if you take square roots of both sides, you get c equals to 5. Okay, would you like to try yourselves if I give you the following details and something, let's say we have something more difficult, 60 and 11. Okay, you may want to pause the video right now and I'll give you the answer in a bit. Okay, welcome back. So if those of you who have tried it using your calculators, you will notice that this would be actually 13 and this would give you 61. Okay, how do we get that? It's the same steps as what we did over here. Okay, so if we label this as a and b, a squared 25 plus b squared, okay, 12 squared, which is 144, you get 169, which is the square of 13. Therefore, you will need to square root that to get 13. In this case as well, if you do the same steps as this, the example, you'll be able to get 61. All right, take it slowly. Make sure that you get the right things, the right numbers in place. Use your calculators carefully and just continue trying. Okay. Now, these are the common Pythagorean triples. Spelled wrongly. It's not trips. It's triples. 3, 4, 5 is the easiest one to remember. Followed by 5, 12, 13. These are numbers that can come out during exam, or you should be able to see patterns in these numbers and therefore identify a triangle is a right angle triangle. Okay, this is something that to take note of. Now, why is this useful? It's useful because if this is a right angle triangle and given sides 1 and sides 2, we are able to find side 3 using algebra and without without you having to use any complicated mathematical tools at our favor. So as I said again, the condition for Pythagoras theorem, it needs to be a right angle triangle for you to use the Pythagoras theorem. If the triangle isn't a right angle triangle, I'm sorry, you can't use the Pythagoras theorem. You have to find the right angle triangle. So for example, in this case, there is actually a right angle triangle hiding inside this square. Okay, you can see if I draw a horizontal line, sorry, a diagonal line across the square, you see that two right angle triangles hiding inside. And if this is a square, let's say of 4 cm, using the Pythagoras theorem, you'll be able to find the diagonal of the square, which is, let's say we name this C and A. Okay, so A squared plus B squared equals to C squared. This is the mathematical formula that's also associated with the Pythagoras theorem. A squared is 4, B squared is similarly 4 equals to C squared. 16 plus 16 equals to C squared. 32 equals to C squared. Therefore, you square everything both sides. 32 equal C would be square root 32 units. Okay, that's how Pythagoras theorem can be useful. Another way we can use Pythagoras theorem, it's proving that this triangle is a right angle triangle. Okay, so how do we prove? We need to look at the length of the triangle. So for example, if we have 5, 12, and 13 over here, how do we prove it? Okay, we know that this is the hypotenuse because this looks like the longest. Remember, we said that the hypotenuse is the longest side of a right angle triangle. So before we can identify that this is the hypotenuse, this is the longest. We identify this as the longest side. So we assume first that this is the hypotenuse. So we need to check. Okay, we need to check that 5 squared plus 12 squared equals to 25 plus 144, which gives you 169. Now, if you square root 169, remember that our formula is a squared plus b squared equals to c squared. Okay, so you're looking for if you want to identify if this triangle is a right angle triangle, we need to see whether or not the square root of the sum of squares of the both sides is equals to the square of the longest side. Okay, so the square root of 169 is indeed 13. So using your Pythagoras theorem holds because 5 squared plus 12 squared equals to 13 squared over here. So by being able to identify and prove that this relationship holds, you are saying that the Pythagoras theorem can be applied to this triangle. Therefore, we can conclude that this is a right angle triangle. So basically, a recap, the Pythagoras theorem is a useful relationship. It has a useful relationship to inform us how the sides of a right angle triangle relate to each other. It allows us to find the different sides of the triangle, and it allows us to identify. It's a way for us to identify if a triangle is indeed a right angle triangle. So thank you very much for tuning in tonight. As I said before, I'm doing this to help my students. If you have feedback, if you have suggestions of how to make this better for yourself and how I can better help my students, please do leave your comments below, and I will be sure to take them, and I will hope to see you all again. Thank you very much and good night.